In this lesson, we'll talk about Databricks machine learning. So in Databricks, as you know, Databricks is a platform for a lakehouse platform. So that means you can do machine learning, you can do data engineering, you can do data warehousing, you can do lots of data activities in Databricks. One of them is machine learning. And Databricks supports different kinds of clusters in order to perform the job. So if you go to our cluster here, if you are in the compute page, you see the cluster. We already have a cluster created. One slight change we need to do to this cluster in order to be able to do the machine learning on Databricks. So if you click on this cluster here, and then click edit, and then go to Databricks runtime version. I already did the change, but I will show you how to do it. If you click here, you will see Databricks has two different types of Databricks runtime version. One called the standard, and this is the one you would use for doing data activities like reading data, writing data, insert, update, delete, all this kind of thing, right? With a Spark, of course. And the other one here is an ML. So if you click on the ML one, you'll see the list of ML cluster here, right? In my at this time there is 12.1, but in your case could be different, could be 13, 14, whatever the number available to you here. And if you look closely, every machine learning version, runtime version, have two flavors. One that uses GPU and one without GPUs. And GPU is a graphical processing unit, is the one where you have like compute intensive applications like deep neural network, like all kind of application in machine learning that is like heavy on computation. You'd better do this in a GPU. For my case, we don't have this like requirements. So I'm going to use a standard or the non-GPU ML, and always pick the latest one to guarantee you get the best experience and the best performance and so on. So in my case, ML, I'm going to choose 12.1 without GPU. So I'm going to pick this one right here. Nothing else I'm going to change. I'm going to leave everything default and the same. Then you click confirm. In my case, I already did this because the cluster is, as you see, already running. So this is the only change that you wanted to do. The second thing is about machine learning itself and how machine learning runs on Databricks. For that case, if you go to this document here from the Databricks, Azure Databricks documentation about Databricks machine learning guide, you will see that Databricks, I'm going to put this link on the description for you to read it later, but you can see that Databricks says that there is almost 4 stages in order to run the machine learning. The first stage is called data preparation. This is pretty much about reading data from somewhere or the source system. Maybe did some data processing like building the bronze, silver, and gold, and finally pick up either the silver or the gold, pick one of them to move it to the next step, which is either to build a feature store, and this is something we could like talk about later, or do the machine learning training, right? Doing machine learning training in Databricks, you can do it in different ways. One of them is called automatic machine learning, and this is the one we're going to use today for this lesson. Another one, if you're like an expert data scientist, you can actually write the code. If you know what you're doing, you know what your algorithm, you don't really need some assistant from Databricks, so you can actually write the code itself. And this is all to build some what we call experiments. In these experiments, you can select one of the experiments that you have done from machine learning and say, okay, this one looks like a promising one. It gives me the best prediction, the best ML output. So I'm going to select this one. I create a model out of it. So we got to the model stage. In these models, you can then use the model to predict your, the output for your machine learning. And you can do it in several ways. You can do it as a batch prediction or a streaming prediction. Or if you wanted to have it as an API, request and response, you can also do that in Databricks. We call this the production step. So 4 steps: data preparation, model training, and then you got to the models, and then you do the productionization or the production. We already did the first step, which is data preparation. We already got the data from the source system for the Titanic data set. So we got the data from somewhere, which in our case was Kaggle. We built the bronze, silver, and gold. So we're pretty much done with the first step. Now let's go to the second step and see how we can do it. In my case, I'm going to select AutoML as a way or as a means for you to generate the experiments. How to do that? Now, if you go to Databricks in here, we're still in the compute page. One thing you wanted to do is to switch your persona We have data science and engineering. We have machine learning and SQL. We're gonna pick machine learning this time. And in here, you're gonna see automatic machine learning right there, right? So I'm gonna select start AutoML right there. So we have AutoML now in the AutoML page. The first step that you wanted to do is to select the cluster. Now you need to pick a machine learning cluster. So I'm gonna pick this one. And this is why it appears in the list. If it's not an ML, you wouldn't see it in this list. So make sure you do the step before you get to this page. So you see an ML here. It says ML. I'm gonna select ML. So now I selected my cluster. The second step is to select, okay, what kind of machine learning problem you're trying to solve. Databricks automatic machine learning supports, as of now, 3 different machine learning problems: classifications, regression, forecasting. Classification in a sense that you wanted to classify something from your problem. Like if you, in the Titanic dataset, for example, the Titanic dataset is about, you've got some columns representative of the people who boarded the Titanic. This is like you got their names, you got their age, you got their ticket number, where they boarded the Titanic. This is all features that represent the people who boarded the Titanic. And one column called survived. And this column is a 0 or 1 column. So when it's 1, like mean this person has survived the Titanic. If it's 0, this person didn't survive from the Titanic. From machine learning perspective, because the output is like a selection between distinct set of cases, we call this a classification. So the Titanic dataset pretty much is a classification problem. If it's a regression problem, it's a prediction. In regression, you don't really classify from a set of outputs. You actually generate a number. For example, if you have a dataset representative of employees inside the company, so you got the employee age, years of experience, what skills they have, like AWS, the databases, software engineering, whatever skills you have, and then one column called salary, right? And you wanted to predict the salary. If you're given the skills, how much salary they should be making. So in that case, the machine learning will predict a number. It's not really classification in a bucket or a set of predefined values, but just it could be a real number. So we call this a regression. And forecasting is pretty much predicting a time series. There is events that happens in certain times, and you wanted to know how far in the future you can predict, or what is the value look like in the future. We call this forecasting. Like I said, I'm going to choose the Titanic data set. So pretty much it's a classification problem. So I'm going to click classification in here. And the next step is to choose an input training data set. And in our case, we're going to choose the Titanic. So click browse. You got the databases in here. I'm choosing Titanic. And I'm going to choose the Titanic Silver table, because this is the table that contains the passenger ID, ticket number, all this information, which I'm going to use, and also contains the survived, or we'll call the target table, the target predicting column. So I'll select Titanic Silver, Train Silver, and select. And you can see Databricks has already loaded the data in here, which is nice. Finally, I'm going to select a prediction target. Like I said, the purpose of this Titanic dataset is to predict this column, survive. Did this person survive the Titanic or not, right? Given this information, given their passenger ID, P class, name, sex, age, SIBB, ticket, fare, cabin, all this information. Is this person survived? Did this person survived or not? So we wanted to predict the survived table. This is our target column. So I'm going to select survived. And then if you want to give it a nice name, I'm going to leave everything pretty much the default. Now in the Titanic dataset, so what Databricks will actually do, Databricks will generate a set of, will try all possible classification algorithms that you choose from these libraries. So in Databricks, you can choose LightGBM, sklearn, and XGBoost. sklearn, for example, have different algorithms like logistic regression, like decision trees, and so on. LightGBM and XGBoost, they also one common algorithms for this problem. I'm going to leave this selection the same, but if Databricks will try all algorithms together at once, and even the same algorithm will try it multiple different times with different parameters. So you end up with like 50 or 100 algorithms that Databricks have tried to solve your problem. Which one is the best? This is where you choose the evaluation matrix. When you do machine learning, there is one metric that you need to select to say, okay, how do I judge that this machine learning model is a good or bad, right? For classification, and there's several ones. Classification, I think, works best with F1 score, but you could choose accuracy, log loss, precision, EUC, or area under the curve. There's different ones in here. I'm going to leave it the default, which is F1 score, which is recommended by Databricks or selected by Databricks. And I'm going to let it choose from all different algorithms. I'm not going to restrict it in anything. Now, how long do you want this experiment, AutoML experiment to run? 120 minutes seems like a standard. But in my case, I'm going to leave it like 10 minutes, which is like enough. I'm not going to leave it like for long. And there is other, optional parameter. I don't think this applies to the classification problem, but we'll leave it everything the same, right? Also, on the right side, you'll see the columns from this data set. Now, in machine learning, and this is if you are experienced data scientist, you pretty much know this. You need to normalize the columns. So categorical column. How do you do imputation? Imputation means like if there is a null value, how do you want it to fill this null value? Do you want it to drop the table, the row? Do you want it to fill it with a mean value or a most frequent or constant value? Whatever, the choices. I'm going to leave everything the same. I'm not going to like change any of that. I'm going to leave it the same, running for 10 minutes. And then I'm going to click Start Automatic Machine Learning. Now, what will happen now is Databricks will generate, like I said, all different possible algorithms that could solve this problem, this classification problem. And even the same algorithm, Databricks will try it multiple different times with different set of parameters that could get us to different accuracy. And then the results will appear in this table right at the bottom here. There is nothing yet. I think it's still running training for 10 minutes, but all the experiments will run and show up in here. And you'll see Databricks already. There is one here, I think, already shown up. So I think it started to generate some of the data. The first step the Databricks will show is to generate some notebooks. And every single experiment is a notebook. So I'm going to leave it running for 10 minutes. And in the next lesson, I'll explain to you what is the output of this experiment. So until then, see you in the next lesson.